Hi again. Everyone has a teammate to work with, a pair. Is everyone in a group? Okay, I think you are all set, Juliana.
So hello everyone, welcome. This is going to be the introduction to MicroPython, getting started with the microbit tutorial. My name is Juliana. Just me get off the mask. So my name is Juliana. This here is my handle. So if you want to take pictures and post it anywhere, you can tag me. And I'm going to be presenting myself now. So I'm from Brazil. I studied computer science at the Federal University of São Carlos. And in São Carlos, I am the lead of the Python community. So there I am the co-founder and organizer of PyLady São Carlos, and also the group Pysanca, which is our local Python user group. I work as a software engineer at OmniVector, and I like talking about IoT, robotics, 3D printing, and my kitties. And today, I have some disclaimers for you. So first of all, this tutorial is not sponsored. So I'd like to ask you to please be careful with the devices. And don't forget to return them after the end of the tutorial. And this is going to be a very heart-lighted tutorial, so please have fun. I hope you have a great time here today. And we are going to be working in pairs, as I mentioned, so I think everyone got a partner to work with, so I hope you're comfortable with that. And this is what we are going to be covering today. So first of all, we are going to have an overview about MicroPython. Then we are going to be talking about the microbit, which is the devices everyone has got just now. Then we are going to be seeing the Python editor, which we are going to be using to program the board. After that, we are going to be experimenting with the device, so we are going to have some interactive examples. After that, we are going to be building the project of the tutorial, which is going to be a Battleship game. So the first version is single player, where you play against the computer. And the second one, if everything works out, is going to be multiplayer, so you're going to play against each other. So let's see if we can get there on time. And starting with the MicroPython. So who here is familiar with MicroPython, has used it before? Few people. OK. So MicroPython is an implementation of Python for microcontrollers. And you may be wondering about what is a microcontroller. So a microcontroller is a device, just like the ones we have here. And it contains an integrated circuit. So it has a processor, memory, and peripherals all on a single chip. And it usually has some I/O capabilities. So you can connect the device with sensors and actuators, so you can interact with the physical world. It's also programmable, so you can change the function of it with your own code. And it usually has lower power consumption, so you can use batteries to plug it in. So here we have a pack of AA batteries. AAA batteries, there is enough to power the microbit for a few hours. So coming back to MicroPython, we have here some key points of MicroPython. I'm not going to get into much detail about the implementation itself today. The focus of the tutorial is using the MicroPython itself. So MicroPython is a re-implementation of Python 3, and it's written in C. So it was completely written from scratch. It has a small subset of the standard library. Not everything is included, but we have a pretty good subset there. And it's optimized for constrained environments. So you can run in devices that have only 256 kbytes of code space and 16 kbytes of RAM. And we have some features for those that are used to programming in Python. You can recognize the REPL. So it's really useful for debugging. We also have list comprehension, generators, closures, exception handling, which is pretty neat. And we also have access to some modules to interface with hardware. So we have the GPIOs, where you can control digital parts. We have PWM, where you can simulate analogic signals. ADC, to convert analogic signals to digital. UART for communication, and some more protocols. And that's just an overview about MicroPython. And we have here some microcontrollers that support it. So the first one is the PyBoard, which was the first device that was prepared to use MicroPython. And it was developed by the same person that developed MicroPython. We also have the ESP8266 and ESP32, which are very cheap microcontrollers that you can use for home automation projects. We have the BBC Microbit, which we are going to be using today. We have the Raspberry Pi Pico, which has been developed by the Raspberry Foundation recently. They have a specific microcontroller called the RP2040 that supports MicroPython. And now the Arduino Foundation is also using this chip to create some Arduino boards. So the Arduino Nano RP2040 also supports MicroPython. And Arduino now is developing an environment so you can program their boards with MicroPython inside their environment instead of using C and C++. So let's get started with the Microbit. So the Microbit is a pocket-sized computer for physical computing. And physical computing is the concept of interacting with the physical world using electronics. So you can have sensors to get data from the environment to the device, and you can get actuators where you can interface with the world, like step motors, servo motors. You can have LEDs, everything that can output the input from your code to the physical world. So the Microbit is created by the Microbit Foundation, which is funded by the BBC, the British telecommunication channel. And they have developed the Microbit to be a device for children in the UK. So it was delivered to children that were studying in public schools in the UK. And this device is, even though it's targeted for children, it's very useful for those who want to get started with physical computing. And it's also a very good way of starting with MicroPython, which is why I chose this to be the theme of the tutorial today. And here are some of the components that we have available. So in the back of the board, we have here the reset button, which is very useful when you want to restart your code. So we are probably going to be using this a lot today. We have here the microprocessors. And we have two of them, a CPU and a microprocessor. We have a speaker that you can hear it right now from some of the devices, and this is going to be using a lot today as well. And the Microbit has two versions. So the first one didn't have the speaker, but the second one has, and the ones we are going to be using are the version 2. We also have on the front of the device a LED ID matrix that we can use to display images and text. The logo here is touch sensitive, so you can use it as input. And we also have two buttons, the A and B, that are push buttons that you can use for input as well. We also have a microphone that you can use for interactive projects. And here on the bottom of the board, we have the edge connector. So here we have a lot of pins, I think it's more than 30. And you can use these pins to connect devices like the sensors and actuators that I mentioned that uses the GPIO protocol or the PWM protocol and the other ones that I mentioned. So you can plug it in here using an alligator clip, or you can plug in the hole here using a banana clip, or you can feed it into a connector, and usually you can buy some boards that have the connector to expand the pin so you can use with jumper cables and this sort of devices. So now we are going to be using the Python editor so we can start working with the device itself. And we can now open here python.microbit.org, and you should see this interface here. Everyone all set? Okay. So here on the editor, when you first open it, just make it bigger. When you just open it, we have here a kind of a hello world example. And this is very important here to check the reference. So if you anytime you are working with the device, you have some doubt about how something works, you can check here the documentation, and you can drag and drop the code here over here. So it's very handy. And if you need more details, we have the API. So here you can have access to everything. And you can get all the parameters, all the functions that are available. And the reference is just a more user-friendly guide. Here we have the simulator. So the simulator you can use when you don't have the board available, you can try it on the simulator. Or if you don't want to flash the code all the time, you can check in the simulator first and then upload the version that you want. So here you can play, and we can see this code here being executed. And here's interactive, so you can click on the buttons. You can mute the sound if you have sound here. You can stop. And here's the reset that does the same thing as the button on the back of the board. And here we can send some commands regarding the sensors that we have. So here's the accelerometer sensor that we are going to be using today. So it measures the acceleration on 3 axes. So you can see on the x-axis, the y-axis, and the z-axis. And we have some predefined gestures that we can use. So you can send them here. And you can also see the numbers of the exact value of the acceleration on each axis. We also have here luminosity sensor that can measure how much light is hitting the board. We can check the temperature. We have a compass as well. The microphone that I mentioned that you can simulate the level of sound input you have. The buttons that you can press here or here. And we see if you do this, you can also hold the button. So you don't have to keep holding with the mouse. Here you can simulate input into the pins over here. And here is the radio sensor. So the microbit has an antenna that you can send radio message to a predefined set of groups. And that's why you all have a post-it with a group number. And here you can see when you have the radio messages, you can see in the simulator the message being sent or send a message here. So here we also have the REPL. So you can try MicroPython directly from the simulator here. And it's going to be controlling this board here for the simulator. Okay, so how is the workflow to work with the devices? So it works differently depending on the kind of the browser you are using. So if you are using Chrome or Chrome-based browsers, it has a protocol that supports connecting to the board from the browser itself and submitting the code, flashing the code, and you can get the REPL running on the board directly on the browser so you can troubleshoot the code. So to do that, you need to plug in the microbit to the computer, write the .py file in the editor that we were just seeing. After that, you hit Save to Microbit, and it's going to show up a screen asking you to select the device that you want. And after that, the hex file, which is the converted file from .py to the format the microbit reads, is going to be automatically flashed. So this is a good way of working. But I particularly prefer using Firefox. So the workflow here is a bit different. You need to plug in and write the code. But after that, you need to download the hex file to your machine and then copy the file to the microbit. So when you plug in the microbit, you should see a flash drive appearing on as a device. Let me get one here. Do we have a spare one? Do we have spares? Boards? Yeah. Forgot to grab one. So here, if I want to send here using Firefox, it's going to say that it's not supported. So I need to download the file, confirm and save. And then I can save here and copy it to the device. So I'll grab the file, I'll find the device here, and it shows up just as a flash drive. So when you paste the code into the drive, it may take a while to copy the file over, and sometimes it can time out if it takes too long. So if you see the error 504 or 506 on the screen, it's because the operation timed out, and you can unplug and try again. So it took a few seconds, but we have here the code. So if you all want to try it now, you can do this workflow here, or use Chrome if you prefer. So I'll give you some minutes so you can try it. Do we need more time, or everyone got the Hello World example running? So if you have problems with the devices, you can just raise your hand, and my friends Anna and Julius is going to help you. So we have some spares if something does not work quite right. So just raise your hands, and we can help you. So moving on, I have some examples that we are going to be experimenting with the device components. And you can find all the resources at this repository here. It's under my profile, Juliana Karoline, and the repository is PyCon, Intro to MicroPython. And here's a short URL or the QR code if it's better for you. And I'll give you some time so you can check it out. Everyone could access it. Okay. So on the repository, you can find the cheat sheet, which is a file that I put together with all the commands we are going to be using today. So here I have some excerpts from that file, and we are going to be going over them. So if you want to try it as we go, you can copy from the cheat sheet file from the repository. So the first the first component we're going to be using the device is the display. So the display is a 5x5 LED matrix, and you can define you can use a predefined image for displaying hearts. You can display a duck, you can display an arrow. We have some images predefined for this device, but you can build your own custom image as well. So the format for doing that, the indexing is like this. So it goes for each row, and it's a string concatenated by columns. So you have 5 parts representing each row of the display, and the number represents the brightness of the LED. So 0 is turned off, 9 is the maximum brightness, and you can have anything in between, so you can make different depths in your image. We can also scroll text, so you can pass any string here, and it's going to be scrolling in the display. You can set an individual pixel, so you can pass the coordinates and the brightness. So the coordinates works like this. First you pass the row, and then you pass the column. So 1, 1 should be here, 1, 2 should be here. And you can also clear the display after you have you want to erase something that you have displayed. So we also have the push buttons that we are going to be using for inputting data. So we have the A button on the left and the B button on the right. And we have some methods to access if those buttons were pressed or if they are currently pressed at the moment. And we can also get how many times the button was pressed since the last time you called that method. So you read it now, and it says 0. And you press 3 times and read it again, it will show 3. But if you read it again, it shows 0 unless you press it after you read the counter. So we are going to be doing the first example, which are going to be using the buttons and the display together. So we are going to be showing a happy face when we press the A button and a sad face when we play the B button. So this example is in the repository as well. So let me see. First of all, we usually have a while true loop, so we can keep the device running for how long it needs to be. So it's a good practice and work with microcontrollers to have all the setup here, and then you have a loop for repeating the function that the microcontroller is going to perform. So we are going to be reading the buttons. So here, when you type and it shows the autocomplete, don't hit tab because it's going to do this. So you need to press enter. It's very annoying, but after some time you get used to it. So autocomplete, enter. So we are going to get if it is pressed. If it's pressed, we are going to be displaying an image. And we can see here all the predefined images that we have. So you can try some different images so you can see how they work. Here we have some that are connected. So you have the hands of the clock. We have the arrows. The arrows point to different directions. So you don't need to create our own, you can just use this, and we are going to be using today. And here I want the happy face. And then, if it's not pressed, I want to check the B button. If the B button is pressed, I want to display the sad face. And after that, we are going to be waiting for some time. 100 milliseconds. Sad. I didn't like that. We are going to be sleeping for 100 milliseconds, and then we are going to be cleaning the display. So we can try it here. When we press and hold the A button, it reads as you are constantly pressing the button. So it's always going to check if it's pressed and return true. And the same thing for the B button. So this one should be testable from the simulator if you don't want to flash it on the device. Everyone good? If I go too fast, just raise your hand and I can wait for a little while. Okay, so now we are going to be using the speaker. And as you can see, it makes a lot of noise, so it's going to be pretty funny, everyone trying this at the same time. And the speaker has some built-in modules that we can use. So first we have the music module where you can play predefined music. So the same way as we have with the image, you can press here the dot and wait for it to autocomplete with all the available music. Or you can play your own music by creating here using this format. So you pass the note, you pass the octave, use a column, and pass the duration of how long this note should be played. And you can do this with all the notes that we have, and you can create our own music this way. We also have the second module, which is the speech module, that you can make it, you can pass a string and make it say it out loud. The voice sounds a little bit robotic, but you can understand what it says. And we also have the audio module that has some expressive sounds. I'm not sure what they mean by expressive, but it's interesting, you should try it as well. And we have here all these in the cheat sheet file. So we have another example that is in the repository. I saw someone play this already. So here is a song that I wrote. It's for, the notes here is for a famous Brazilian song. And I'm not sure if anyone here is from Brazil apart from us. But you can try it, and I can say which song it is. Someone was fast. Yeah, so this song is called Asa Branca. It's a famous Brazilian song. And I thought it was interesting to try because it's the only song that I know how to play on the piano, so I could write the notes from scratch. And if you know how to read note sheets, you can try your own music here. So now we can use the accelerometer. So the accelerometer has, you have a way of getting the exactly values, or you can get some predefined gestures. So you can get the values for each axis this way, accelerometer.get x, y, z, or you can read the gestures. So the gestures you can check on the simulator, the ones that we have available. And you can, the same way we have with the buttons, you can check if it is currently being done or if it was done in the past. So we are going to have two examples now that use the accelerometer, and we are going to be using these two different ways of getting the values from the accelerometer. So the first one is the gestures. So you can read the current gesture and show an arrow pointing to the direction of that gesture. So if the board is up, you can show the arrow to the north. If it's down, to the south. If it's west, to the left. And if it's right, to the east. But if you try this, you need to fix something. So I left this like this so you can experiment and fix the direction of the arrow. Something here is not going to be working. So you can try it. And I will type it together so we can do it together. So first of all, we need to read the gesture. Is gesture, current gesture. We get the current gesture, and then we check if gesture up. We just get here. Yeah, we have up, down, left, right. If it's sitting up, if it's sitting down, if it's falling, and how fast it is falling, and if it's shaking. So if it's up, we are going to be showing display show image arrow north. and then we can wait for a little bit and just clear the display. So this one, let me hide this. And we can try sending the up. And you should see the arrow when you are holding the device like this. And the down is like this, left and right, and shaking. So you can try it. And you can see what. Yeah, on Fury, it's up, so you point to the north, but you need to change it so the arrow is pointing to the right direction. So since the cables are short, if you want, you can plug in the battery and remove the cable. You can plug the battery and the cable at the same time. And if you remove the cable, it's going to be powered by the batteries. So you can remove it and change the direction of the board if you need. Okay, so moving on, we have the fourth example, and this one is going to be useful for the game. So we are going to be reading the values for each axis, for the Z and the Y axis, and we are going to be changing the position of a pixel in the display. So depending on the way you tilt the board, you should see the pixel moving. So this example is also in the repository. So here we start with 2, 2, so it's on the center of the display. And if we get some movement to the right, so the x-axis is tilted to the right, we are going to get the minimum between x plus 1, which is something that is going to increase, or 4. So we stop at 4, so we don't overflow the display. And same thing, if it's less than 0, we do the opposite. So something that is going to be going going down, or 0. So you want to cap it at 0. And something for the y-axis. So get if accelerometer x greater than 0, start the variables. If it's greater than 0, so we can update the coordinates, and then we need to display the coordinates. Set pixel, and then we pass the coordinates, and I'm going to be using 9 for the brightness, so it's the maximum. And then after that, we wait for a while, and we clear the pixel. Let me see if it works. Yeah, you should see something like this happening. Let me see. It's why here. Did it work for everyone? Or anyone needs more time? We're good? So now we are going to be using the radio. So the microbit has an antenna that you can use to communicate with other microbits, and it works in groups. Kind of like we have Wi-Fi channels, it works the same way, and it uses the same frequency as 2.4 gigahertz Wi-Fi. So you can use, I don't think it's a proprietary, but it's a specific protocol for communicating, but it uses the same frequency. And you can pass here the group. So you can configure the group by passing a number between 0 and 255. So that's why all desks have a post-it note with a group number. So this number is going to be for you to work with your partner. So if we have more than one group using the same number, it's going to be confusing. So check the number and be sure to work on pairs. Here we have the power, which is the signal intensity. So 0 makes the signal stay here. 7 probably you can reach outside of this room, but we can leave it as the default for now, and if it's not communicating, we can try increasing it. And with the radio, you can send a message. So you pass the string, and it's going to broadcast to that channel. So all the devices connected to the same group can receive that message, and it's not encrypted. Or you can receive the message from the group. So when you call this method here, you can receive the latest message that was sent to the group. So to test this, we are going to be running this example here, the teleporting duck. So the idea here is that we have a duck being shown on your display. And when you shake the board, the duck is going to teleport to the other board. And you can do this back and forth to see the duck going from one board to the other. And this example is also in the repository. So let's do it together. First of all, radio on, radio config, import radio. Group, and you define your group number. I'll put 0 here just for reference, but you should use the number on your desk. So if the accelerometer is being shaken, we clear the display, so the duck disappears. And we send the message, duck. And if we receive a message, if we receive the duck, we can display the duck. And we wait a little bit just so we don't run this too fast and try to read the message before it arrives. Did it work?
Yes, there are. So radio.send is taking a string of a duck and it knows to make a duck. So there's different functions.
No.
Oh, right there. I see it. Yeah.
When you receive the message, you specify the image that you want.
Yeah, I read the code. Who reads code? Wait, let me see. I want to send you some other stuff. Oh, yeah, no. It's just going to change it for me.
Yeah, yeah. We're just experimenting, me too. Yeah, so
Yeah, if anyone needs help, just raise your hand and we can come help you.
I do tortoise.
what we do.
I want to do tortoise.
And then I go on computer and then pushes it to AWS and do a lambda that sends me a text message of the temperatures if they drop in the garage below like, freezing or below 40. That's amazing. Yeah, because like you could do lambda and then you could have that SMS send a text message.
Do we need more time? Or did it work for all the groups? We're good? Okay, so now we can start the first project that we are going to be working today, which is the Battleship game. So first we are going to be doing a single player version of the game. And this is how the game is supposed to work. So you can press both buttons to say you are ready to play. And then you can tilt the board to decide where you want to shoot. And you can shoot with the A button. So here I'm very terrible at this game. I'm not finding any ships. And there we go. So now I need to figure out if it's in the horizontal position or the vertical position. And it is in the vertical. And it's just 2 dots there. So this is what we are going to be building today. No. So we are going to be looking over the code. We have the templates available in the repository, and we also have the complete code. So don't look at the complete code just now. Wait for the end. So it's going to be more exciting. The first class that we have is the C. So the C is going to be storing the ships that the computer is going to place randomly in the display. And the C also checks if your shot hit any pieces of the ship. We also have the player class that is going to handle the logic of the shoots. So you can shoot on the C and see how many shots you have already taken and if all of them has hit any ships. And we also have the game class. That is the game loop, so it's going to be running until you hit all the ships in the map. So first of all, how we are going to be populating the sea with ships. The idea here is that we are going to be having this placement here, and it's random, so that's why I'm trying to show different positions here. And you can see that they are not touching each other. So that's because we have a rule here that, first of all, we need to place the biggest ships first, because if you place the smaller one first, the big one may not fit, so you need to place the biggest one first. The location matters, so you cannot put on the edge of the board so it would overflow to the right or to the left. And the chips must not be touching, so they must be surrounded by water. All the edges must be surrounded by water. And here's an example of a valid placement. And here it's impossible to place the last one because we don't have space here that would not be touching any of the other ships. So here is how the algorithm for generating the C works. So first we are going to be generating a matrix, a 5 by 5 matrix, that we are going to be filling with water. So water is a constant that we are going to be defining a brightness. So everything that is water should be just barely visible. Then we are going to be populating the sea with 3 ships. It's going to be 4, 3, and 2, the length of the ships. And we are going to be checking if all the ships are placed, and it's going to finish when we have the 3 of them placed. So first, we try to place the first one, and we do that by selecting the coordinates where we have only water. So we have the available coordinates, and we are going to be getting one randomly and checking if it's possible to place the ship there. So we need to see if it fits in the board, if it's not going to overflow, and if it's surrounded only by water. If not, we are going to be trying it again until we find a valid position. And after that, we place the ship, and we try to place the other ones. So if one of them fails, we need to clean everything and try again until we finish placing the 3 ships. So if we get this position here and we cannot place the last one, we can erase everything and try again. So if everything is placed, we finish setting up the game board. So for this part, we are going to be analyzing the template1 file in the single player folder. This one we are going to be going over, but we are not going to be changing anything. We are going to be changing the next ones. So first of all, we need to generate the board. So we are going to be generating a 5 by 5 matrix and filled with water. So water here is brightness 2, and the ship is going to be brightness 9, so it's very visible. And we are going to be trying to populate the ships. And something very important is that we defined the matrix like this. So we have one line, one inside one list for each row in the display. But the indexing of the display works differently because you need to specify first the column here. The X represents the column. And then we try the rows, the rows. So the indexing here is going to be different because first we need to find which of the lists we have. So it's going to be the row. And then we decide which item inside the list we want, which is the column. So the indexing is different. And when we need to address a specific pixel, we need to pass co-row instead of row-co. So all the other operations are going to be using this indexing here. Just when we need to set up the pixel on the screen, we are going to be using this other indexing. So just keep that in mind. So how we are going to be populating the board? We are going to try to place all the ships. This function here returns true. So we can check if all the calls here return true, which means all the ships have been placed. If not, we reset the board and we try again. So usually it takes 2 or 3 times to get it placed. It doesn't take too long. So how we do the placement of one ship? We get the size of the ship, and then we find the coordinates that are candidates. So the candidates are everywhere that we have only water. So in this case here, we have a ship here. So these are not candidate coordinates. All the other ones are. So we can try placing our ship on any of these candidate coordinates. So while we still have coordinates available. We are going to select a random one, remove from the list, so we don't try it again if it fails. And then we choose an orientation, so if it's going to be vertical like this or horizontal like this. And after we decide the orientation, we check if it's possible to place this size of ship in this orientation in that specific coordinate that we selected. And if it's possible, we finish this loop here and we can go to the second part. If not, it just fails here and we can try again once we go back to the place all ships function. So how we check if it's possible to fit the ship? So the idea here is that we must have this placement. We must have water surrounding all the parts of the ship. So this is our desired placement. So we are going to be checking each part of the ship. If it's in the horizontal position, we are going to be checking if there are ships near that position. And if it's if it's in the horizontal position, we are going to be holding the roll and incrementing just the call. So we are going to be checking, incrementing from left to right to check if the ship can, if we don't have any ships near that ship on the map. And if it's in the vertical, it's the opposite. We increase the roll, so it's going to be doing like this, and we hold the call. And if there aren't any ships near, we can return true and continue with our function. If we have any ships there, we can return false and try again. So the near ships function is going to check if we have water surrounding all the parts of that coordinate that we selected. So if the coordinate is invalid, so if it's more than 4, it's going to overflow the screen, so it's not possible. So we are going to check here, one row below, one row after, one call before, one call after. And we are going to check for the positions in all these rows and calls if we have a ship there. So if we try the first one and there is a ship, we don't need to test the rest of them. We can just return false and continue. If we check all of them, we go around the coordinate and we see that everything is water, we can continue with our code. And then after we do these validations, we can finally place the ship on the board. So the indexing is the same as we saw before. If in the horizontal position, we are going to be placing like this, in the vertical like this. And we pass the ship constant, which is the 9 brightness that we set before. And then after that, we can return true because the ship has been placed on the map. We also have another method that is going to check when a player makes a shot, if the shot hit a ship or not. So it's very simple. We just need to check if that coordinate has the constant ship, which means that we have a ship placed there. And we are going to be using this once we work on the player class. And now that we have our board populated, we need to display it for the user. So we are going to be using this on the multiplayer game. So we have this matrix, and we need to translate it into this string, which was the format that I mentioned that we use to display custom images on the board. So we are going to be translating this matrix to this string, and we can see this result here. So this is how we do. It may look complicated at first, but we are going to be creating one string for each line, and then we are going to be joining them by the column. So we create one string, join of them, and we have a big one. And you can try the template one in the simulator or in the board if you want. The template one is ready, we don't need to edit anything. And then you should see the different placements you can get when you press the reset button on the back. Do you need more time? Okay, good. Okay, so we are going to be analyzing now the player class, which is the part that handles the shots. So how we are going to be shooting the ships that we want to sink. So the player class starts like this. We have the shoot board, which is a 5x5 matrix similar to the one we have, but it's going to be only zeros because we want everything turned off at the moment. And we initialize the coordinates 2 and 2, so it starts on the middle of the display. And then we are going to shoot. So we check if the A button is pressed, which is how you make your shot. And we check the acceleration in the z-axis, in the x-axis, and we update the coordinates in the column because of that difference in the indexing that I mentioned before. And we do the same thing for the y-axis, and we update the row. And we are going to be blinking the pixel in the display so you can see where the pixel is positioned. And after that, we are going to be checking if the A button is pressed. If it's yes, we start that coordinate, and that's it. You have updated the coordinates for the player. So for this one, we are going to be working in this together. So open the templates2 file in the repository. Let me get here. Okay, so going over what we have in that template. First, we have the initialization of the player board. So we have the matrix with 0 for representing that we don't have anything there yet. And the coordinate starts in the center of the board. And then we are going to be marking. When you finish taking your shot, you can mark in your board if you hit a ship or if you hit the water. So we are going to be having a similar matrix as we have with the sea, but the sea already has the ships, and the shots only has the positions you have marked when taking your shot. So this is how we are going to be shooting. It's similar to the exercise we did, but for this one, since we need more precision, we have a threshold to make it go slower so you don't go all the way to the edge when you turn just a little bit of the board. So how we are going to be doing that? We are going to be looping until we have the button A pressed. We are going to be showing the board so you can know where you have already selected. We are going to have the threshold to filter these small movements from the readings. We are going to be updating the row using the y-axis value, updating the call using the x-axis, and we are going to blink the coordinate and the value that we have on our board so we can see what is happening there. So for this one, we are going to be writing it together. So here we have the template. And here we have the method that we need to write. So is the font okay? You can read it? Let me just remove this and this. Bigger. Good? Or more? Try more. Okay, so first of all, we need to check if the button A is pressed. So until we have that pressed, we are going to be doing the updates that we saw before. So we are going to be showing the board. So you can see where you have already taken your shots. And then we are going to read the accelerometer. So if it's bigger than the threshold for this is 400, we are going to be updating the coordinates. So The threshold works like this. The accelerometer goes from minus 2000 to 2000. We want to exclude the zone here where we have minus 400 and 400. So we are going to be excluding the middle part, and we get only the extremes of the interval. So self-bound show, where's show? Oh yeah, because I haven't finished typing. Okay, so we have the show method, and then we get the call updated using that logic that we saw before. Minus threshold, the max call -1, 0. And we do the same thing for the y. And the y updates the row. And then after that, we need to blink the coordinates. So I did not. The blink is here. Oh yeah, everything needs to be here. And then we need to pass the row and the call. So this should get our player shooting on the board. Okay. And then we can try on the device because it's much more fun than the simulator. But here, if I press A, it should mark where I shot. Do we need more time? No? Everyone got it? Okay. So you should have something similar to this. and we can try it on the device if you want, if you haven't already. So everyone tried this? Good? Okay. So now we can go to the last part, the last class, that is the game class, which is going to control the logic of the game. So for this one, we are going to be using the template number 3 in the single player folder. And the logic for this one is simpler than the multiplayer one. So we are going to be instantiating the class C and the class player, and we are going to run the game loop. So we run a start routine, which is the music and pressing both buttons to indicate that the player is ready. And after that, we are going to shoot. So we take our shot, we mark it in the board, and we check if it hit a ship or not. If it hit, we play a victory sound. If it didn't hit, we try again. And if we hit all the ships, we do the engine routine and finish the game. So it should be pretty straightforward. So initializing the game class, we are going to be instantiating the C class and the player class that we worked before. And we have the winning condition. So if we get all the ships marked in the player's shot board, we are going to return true because we have hit all the ships. If we find a coordinate where there is a ship and the player did not hit that ship, we can early return false, so we don't need to check everything. So we can't just compare if both boards are equal, because if we have the player hitting the water in a place, if they haven't hit the water, it's going to be 0, and the water in the C map is number 2 in brightness. So you can just compare, because you can, if you are very good at this game, you can hit all the ships and doesn't hit any water. So we need to check where we have a ship and where we have a shot. So here is the starting sequence that we are going to build now. So we play the song, and we wait for the player to be ready to play. So they play both buttons. We just play a countdown and get ready for the game. So how we are going to be doing that? We are going to be greeting the player with the sound and the image. We are going to wait for the input. So we are going to be keep blinking the image until we press both buttons. After that, we are going to be displaying the countdown to indicate that the game is about to start. And when we finish the game, we have hit all the ships. So we are going to be displaying a positive image, a happy face, and play the engine sound. And you can choose the song that you find that is appropriate. So we are going to be writing these methods now in the template number 3 in the single player folder. Let me get the template number 3. Okay, so here we have the things we worked before. So we have the C, we have the player, and now we are going to be working on the game. So the starting routine. First, we are going to be displaying an image. Show image. And I like the target image, but you can choose the one that you want. The target one is very appropriate because we are shooting in a target, so I find this one appropriate. And the music that I chose was the entertainer. Music play, music entertainer. And then we are going to be blinking the image until we press both buttons. So while not button A is pressed and button B is pressed, we are going to blink the image. So we clear the display, clear, we show the image, we sleep for a while, we sleep for a while. And then after the player hit both buttons, we can start the countdown. So for number in 3, 2, 1, we display the number. We play a sound to make the countdown. Bading. And then we sleep for 1 second, so our countdown is 3 seconds. After that, we clear the display. So this should work. Let me see here, we just need to uncomment the start on the bottom of the template. So let's see. And then we can hold both buttons, and the game starts. Did it work for everyone? Okay. So now we are going to be doing the end method in the same template. So the end is just here. The end we can play, we show a happy face because the player won the game. And we play a song.
How did you press both the buttons at the same time?
You have here, just remove this. You have here on the buttons, if you expand this menu, you have hold for them. And then to check the end routine, we can uncomment the end on the last line of the template. Okay? So we should have something similar to this. And now we can work on the run method, which is the game loop. So the game loop is going to play the start routine that we just wrote. And we are going to keep looping until the player wins the game. So we do that by reading the shot, checking with the C if we hit any ships, and checking if we hit all the ships so the game can finish. And after that, we display a feedback for the player to know if they hit or they missed a ship. So we are going to continue working on the template number 3. We have the win here, and then we can update the run method. So for the run, first we need to start the game. And then we need to do the while true, because the game is going to run until we finish the game, so we can because I'm already inside the game class. So we are going to be looping this. And we need to check if the player, we need to take our shot and check if the player hit anything. So self player shoot. And then we consult the C to see if we hit a ship. And then we need to pass the coordinates. So it's the player roll and the player call. Let's remove this. Okay, the player roll, the player call. And then after that, we need to mark our board with the row, the call, and the result. So if we hit or not our target player. Very cool. Okay. So now we have taken our shot and marked our board. So we can check if we hit or missed, we can display the feedback if we hit or miss the ship. So if we hit, we are going to be doing a good feedback. So we display the target because we hit the target, and we play a song to indicate a positive feedback. So music play, music power up. And then we can check if we won the game. So we need to consult the win method to see if we won the game. We can run the end routine. So we can check if we won just inside the hit method, because it doesn't make sense to try to check if you win if you haven't hit the last ship. So we do this and we finish the game. So we do a break here. Break. And if we didn't hit, we display no, because we missed the target, and we play power down. Music, power down. And this should be enough for our game to run. Is anyone still copying? No? Okay, so we should have something similar to this. And now you can try it on the microbit, and we should have our single player game ready to play. So you can try it now. Sure. For him. Good? Okay, so who has finished the game and won against the machine? at least one time. Okay, so I think we're supposed to have a break now at 3 p.m. and we can come back at 3:30. Okay? But if you want to stay and keep playing, you're good. Well, I think we have everyone here, so we can continue with the tutorial. So now we are going to be doing the challenge, which is making this game multiplayer. This is where things get complicated, so this is what is supposed to happen. We have 2 players, one using each board, and after we start the game, we need to select who is player 1 and who is player 2. And then player 1 is going to send their shot to player 2, and then player 2 is going to send their shot to player 1. And you are not supposed to see each other's board, so you don't know where the ships are located in your opponent's board. And whoever gets all the ships before wins the game. So how we are going to be doing the multiplayer game? The part of the sea we are not going to change because we are going to use the same algorithm. The part of the player we are also not going to change because we have everything we need for shooting the targets. And we are going to be changing the game part because we are going to need to handle the publisher and subscriber logic. So how is the logic going to work? We are going to be analyzing template 1 for this part. And we need to finish all the parts in this template so we can run the game. We cannot test each one as we did before because all of them needs the other ready so we can test everything together. So it's template number 1 in the multiplayer folder. Okay, so here is how the algorithm for this part is going to work. I hope it's readable for you. So we are going to be creating 2 instances of, one instance of C and 2 instances of players, because one of the players is going to be me.
Someone's asking to repeat the game mechanics again, who's the winner, who's the loser.
Oh, okay, I think we're going to cover this now. So how we are going to work here. We have 2 players. One is playing against each other. And the one that hits all the ships first wins the game. So if if all of them gets the shots right all the time, the first one wins, because the first one is going to finish first. But the idea is that one of them is going to finish first, and the one that wins gets a positive feedback, the one that loses gets a negative feedback. So the winner is whoever hits all the ships first. Is it okay? Yeah, but we are going to be communicating from one board to the other using radio. Okay? So we have 2 instances of players. One is going to be me, the other one is going to be the opposite. And both boards are going to have the same code running, but we are going to have a logic to define who is the player 1 and who is player 2. So first of all, we define our group, because we are going to be using the radio. We run the start routine, as we did before, the one where everyone is ready to play. And then we are going to choose the players, which is the first function we are going to be doing now. So to choose the players, one of them press button A, that is going to be player number 1. The other one press button B, is going to be player number 2. So you need to coordinate with your partner who is going to be the first player and who is going to be the second player. So after you choose the players, we need to start the game loop. So if you are player 1, you are going to be sending your shot first and then receiving the opponent's shot later. But if you are player 2, the logic is inverted, because player 2 starts receiving the shot, because player 1 is going to play first. And player 2, after they receive their shot, they send their shot to the opponent again. So here we are going to have a loop here, where player 1 sends a shot. Player 2 is going to reply with the result. So you're going to say, oh, you hit my ship, and you hit my ship, and you haven't won the game yet because you haven't hit all my ships yet. So that's the response we get from player 2. And then we are going to be marking our board with the result that we got from the other player. And then we are going to check. If I hit a ship, I'm going to play the victory sound and check if I won the game. If I missed the ship, I'm going to wait for the other player to play. So I sent mine, they replied. Now I need to wait for them to send theirs, and I will reply. So we have this publisher-subscriber logic. One publishes, the other responds, and then the other publishes, the other responds. So we are going to have the two boards communicating with each other. So now I wait for the shot for the other player. When I receive a shot, I need to check if that shot hit my board, hit a ship in my board, and if it did, I can reply to the user saying, oh, you hit my ship, and you haven't won the game yet, or oh, you have hit all my ships, the game can finish now. So I'm going to inform the result for the player, and now I have to track both boards, mine and the opponent, because I need to know where the opponent hit, so I can see if the game ended, but I also need to track mine, so I can know where I have already shot before. So we have the two boards, because we have two instances of players. And then it's the same logic when we receive the shot. We check if they hit a ship, but if they hit, we are going to play the defeat sound, because it's bad for us if they sink our ship. And we check if the player if the opponent wins the game, we finish with a sad ending because we lost the game. So the logic is going to be inverted from one player to the other. So the init for the game in this multiplayer version, we are going to have the two instances of player. We are going to store who is the winner. So of course it starts empty in the beginning. And we need to turn on our radio and define our group, the same way we did with the other exercises. So you have the group number in your table. So the start is going to be the same as the single player version. So we wait for the input, display the countdown, and clear the screen. And then we have a method to check if the game finished. So only the person that is receiving a shot can know if the game finished, because only that person knows where their ships are. So only they can know if the player hit all their ships or not. So to check, we see if our C has a ship and the opponent hit all the ships, it's because they won the game. So if we check all the parts where we have a ship and we find one that the player hasn't hit already, it's because they haven't won the game yet. So we can early return false. And if we check everything and they hit all the ships, they won the game and I lost the game. So only the player that is receiving the shot can check if they have lost the game. And the end now is going to be different depending on which player won the game. So if I win the game, it's happy for me. If I lose the game, it's sad for me. And we have here the appropriate music for each of these occasions. So how we are going to be choosing the players? We are going to be displaying this bolt to wait for the input. whoever presses button A is going to be the player 1, and we display an arrow pointing to the button A to give a feedback that they have already pressed the button. And for player B, for player 2, we display the arrow pointing to button B. So you need to coordinate who is going to be 1, the first player, who is going to be 2, the second player. So this is how we are going to be doing this. The same thing that I already mentioned. Display the image, wait until they are ready to play, and then 1 is going to select button A, and wait for a response from player 2. So if I press the button A, I am player 1, so I need to send, oh, I am ready to play, I'm player 1. And I need to wait for a response saying, oh, I'm ready to play, I'm player 2. So the player 2 presses the button, the B button, and sends that message to the player 1. And after we have this message, one saying that it's ready, the other one saying they are ready, we can start the game. So we need both of them ready to play. So now we are going to be writing this method using template number 1 for the multiplayer folder. And we are going to keep iterating into this template until we finish the multiplayer game. So let me grab my template. Okay, so here you need to define your group number with the number you have on your table. The C is the same as we did before. The player is the same as we did before. We only have one more attribute here, which is going to store who is the player 1, who is player 2. The rest is the same. And now the game, we have the part that I showed just now. The start and the end is this that we just saw. So the start is the same as the other one. The end is different depending on who wins the game. The loss that we just saw. And now we can start choosing the players. So to do that, first of all, we display this image here. This is supposed to be a boat. So you can change if you want, but it seems appropriate since we are having ships in Battleship. So we can start choosing the players. So we are going to be looping this for a while. And then we are going to check. If I press the button A, it's pressed, I'm going to send my message saying that player 1 is ready. So radio send, player 1, ready. And then I need to wait. Can sleep for a while. Just a little bit, so we wait for the message to finish sending. And then we need to see if player 2 replies to our message that we are ready. So we are going to check if player 2 is going to reply. So we try to see. We try to receive the message. And if we have the message, we can do what we need. So first, we need to check if the message is from player 2, saying that they are ready. So player 2 says that they are ready. So I am player 1. And the opponent is player 2. So I am player 1. The other player is player 2. So I can show on my screen 1, just so I know that I am player 1. And here, we want to give the feedback to the user that they pressed the A button. So we can, the A is on the left, we display an arrow to west. And then we sleep, the sleep should be after this. Okay. So we display the arrow, we wait for the message, we receive the message, we assign the players, and we display that we are player 1, and we can break this and break this. So we have defined that we are player 1. Now we need to do the opposite for player 2. If the player pressed button 2, they are going to wait for the message for player 1. So we receive the message and check. If message and the message is player 1 ready, I'm going, after we press the button, we can display the arrow. So display show image arrow east. Okay, so we display the arrow, and we keep waiting for the input from player 1. So we received the message, and player 1 is ready. So I am player 2. The other player, the opponent, is player 1. I display number 2 for me, so I know that I am player 2. And then we can break here and break here. So we have a sleep after we send the message, and we should have a sleep here to not try to read this too fast. And here as well. Let's see. Let me see if I can fit it on the screen. Is it too small? Yeah. Which part do you need? From here? Or up? Okay. So we finished setting up our players. We wait for 1 second. Yeah, I do. I received the message. I need to reply that I'm ready. Thank you. So now we should be good to go. So just going over, we send the message player 1 is ready. We wait for message player 2 is ready. We wait for the message player 1 is ready. We send the message player 2 is ready. And then we assign the player numbers for me and for the opponent. So we have something similar to this. So now we can work on our next method, which is going to be sending our shot to our opponent. So we are going to run our shoot method to update our coordinates. And we are going to be sending a message with the role and the call where you want to shoot. And after that, we wait for the response from the opponent saying that they received the shot, and if we hit, and if we won the game. After that, we are going to mark the result on our board, because it's my shot. I'll check if I hit, I will celebrate, and I return it true to indicate that if I won the game. So we are going to use this return true as a stopping condition to finish the game. So if I won, it's true. So we are continuing editing the template number 1. So now it's this function here. So first we start shooting. This. So I am going to shoot. And then I need to send my message saying where I want to shoot. So unfortunately here we don't have f strings, so we need to convert self.me.row self.str self.me.co. So this is going to be our message. And now I need to send this. And wait for a while, just to ensure everything went through. So we are sending our message, and now we need to wait for the response from the second player. So my response starts as none. And I'll loop here while not response. Radio.receive. And then we received the message, and we wait if we didn't receive, so we don't try to read this too fast. So we received our message, so now we need to process this message. So we need to extract the values. Split is split. We extract the values, and we convert the values to int, because they come as a string. So, no, we sent our shot, and we are going to receive if the player hit and if they won the game. Response split. And then we check, we convert this to bool. So we check hit receives. Hit is equal to true because it's coming as a string. And won is equal to true. If it's not true, it's because it's false. This is going to return false. We are going to get false. So now we can mark our board with the result of our shot. So we pass the row, we pass the call, we pass if we hit. And it's me, because I am the one that is shooting. And then we need to check if we hit to make the feedback. So if we hit, we can do the same thing as we did before. So we display the image target. We play powered up. And that's our celebration. If we miss it, we display no. And we play power down. Power down. And then we need to check if we won the game. So we are going to be doing that on the loop. So as I said, if we won, we return true. So we just return the one here. So this value comes from the other player, saying, oh, you hit all my ships, the game is finished. So we are going to store this value to use in the game loop. So we must have something similar to this. Oh yeah, and we need to sleep for a while so it doesn't run too fast. Everyone okay? Okay. So now we sent our shot to our opponent. We need to receive their shot. So when we are receiving their shot, we are going to be displaying our C-board so we know where we have our ships. The other player must not see that screen because otherwise they will know where they have to hit our ships. So we see our board, our C-board, and we are going to wait for the opponent to send their shot with the coordinates where they want to hit. And when we receive that message, we are going to be blinking the coordinates so we can see on the display where that shot was taken. So you can see if they hit your ship or not. And then we are going to check if the shot hit our ship. And we are going to be marking the shot in the opponent's board so we can keep track. And then we are going to use the opponent's board to check if they hit all of our ships. So if they did, we send to them, oh, you won the game. And this is our response, if you hit a ship and if you won the game. And after that, we are going to show the result. So we are going to display no if they hit, because the target if they hit, but the player down because it said for us that they hit our ship. Or the opposite, if they missed the ship, it's good for us, so we display the power up music, so it's a good feedback. And then this function here returns true if the current player lost. So when you send a shot, it's true if you won. When you receive a shot, it's true if you lost. So in either case, it returns true to end the game. So now we can continue working on the template, but now we are going to be doing the receive shot. And I can see just now that I put this in the wrong function. This one is the send shot. And now we are going to be working on the receive shot. Okay, so we are going to be showing our C, so we can see how our map is looking. And we are going to wait for our opponent to send their shot. So while we don't have a response, we try to read the message. So now we have our response, and we also need to sleep here so we don't read this too fast. So now we have our response, and we need to extract the values, to unpack the values. So now it is the row and call that I was doing before. So let me do this. So row and call, receive, response, split. We cast it to int. And then we can check if we can blink the coordinates and then check if the players hit anything. So C blink is the C. And then we pass the coordinates that we want to blink. So it's the row and the call that we just received. And now we can check if our opponent hit our ship. So our C is going to say, because only the C know where the ships are located. So row call, and then we receive the response here. So they hit the ship, and if they hit, we need to check if they won the game. So they hit the ship, and we mark their shot. Sorry. So we show the result of their shot, so where they shoot. We check if they hit a ship, and then we mark in the opponent's board, because we need to keep track of where they have already shot our map. So we track this. See the hit. and then we pass the hit here. That's what it's containing. So we are going to mark where the player shot and if they hit a ship or not. And then, after we do that, we check if we lost the game. And then we reply to the user with this message. So we say, oh, you hit the ship, or you didn't hit the ship, and we won or you lost the game. So for this player is lost because the other player hit my ship, but for the first player it's won because they are the one winning the game. So we have our message, we send our message, we wait for a while, and we should be good now. So the other player knows the result of their shot, so we can do the feedback. So if they hit, for us it's sad, but we need to display that they hit. So we display the target, and we play power down. If they didn't hit, if they missed the shot, it's a no, but it's a power up because for me that's good. And we return if we lost the game or not. Okay? So we have this. Should have something similar to this. And now we can do our game loop, the run method. So this one is going to be a little different from the single player version, but it starts the same with the starting routine. We choose the players, which we have just completed. We know that player 1 must shoot first, and player 2 is going to receive first. So we have this logic inverted here. And we check, did the current player win? So when they send the shot, did it return true because they win the game? That's the condition to end the game with the happy ending. But if the player receiving a shot returns true, it's because they lost the game, so we trigger the sad ending. So we can do this now, continue editing the template number 1. So we are going to have a while true loop. And then we check, if I am player 1, I will start shooting. And I need to check. If this returns true, it's because I won the game. So winner receives my number, and we break the loop because the game finished. After that, we need to receive the shot. So if we receive and it's true, it's because we lost the game. So the winner is going to be our opponent. We also need to break the loop. And we are going to keep continuing this. So player 1 shoots first, receives. Shoots first, receive. And this is going to be our loop here. And if we are player 2, it's the opposite. So we start receiving. And if it returns true, it's because we lost the game. And then we can finish the game. But if they do not finish the game, we are going to be sending our shot. And if we send our shot and it returns true, I am the winner. And we break. So this is our logic. And after we finish the game, so we broke the loop, we can finish the game. So self-end. And we need to know if it's a good ending or not. So we check if the winner is me. The only thing missing here is that we need to start the game, of course. So we start, we loop until the game finishes. After it finishes, we end the game. Okay? So we have this. So now it's the part where we need to figure out if this is going to work. So you need to decide if you are partner the group using the number we have. Both of you need to update your versions of this file to the board, and you can try to play against each other. Okay, so just remembering, you need to decide who is player 1, who is player 2. One of you press button A, the other one press button B. So you can start the game. And you always press A to shoot, independent of which player you are. Okay, so did everyone got the game working? Is there any groups that couldn't get it working yet? Yeah. Yeah, I faced some communication errors when I was testing, because sometimes the message doesn't get sent or doesn't get received, so it can crash.
Yeah, so I got her here.
Okay, so now that we get the project working, we can think about some improvements that we can make. So I thought of 3 improvements. The first one would be tracking the score, so you could see how many shots it took for you to finish all the ships. We could try creating our map dynamically, so you can decide where you want to place your ships instead of having the algorithm to generate it for you. And we could mark when the player hits your ship. Instead of just blinking the coordinates, we could mark with a different brightness where they have already shot in our map, so you can see how many are left. So these 3 improvements would be nice to make. And you can think of other improvements that you would like to make. So I'd like to thank you everyone for attending. I hope you have enjoyed it. It was supposed to be a more fun, interactive tutorial, so I hope it was what you were expecting. And if you want to check more games using the microbit, yes, last year at PyCon US in Salt Lake City, I presented a talk where I created 3 interactive games, and it's on PyCon YouTube channel. So if you want, you can check it there. And I want to make a request here. So I'm going to be, if you can reach me on social media, my handle here is Juliana Karoline on all these social medias. And I'll be going to post there about an open space. I'll try to make a MicroPython Works open space during the main conference. So if you want to keep playing with the boards, if you want to chat about MicroPython, you can find me there. And I'll post on my social media so you can see the time slot and the room where we are going to be meeting. And I think that's it. So I'd like to thank you all for attending. And before you leave, I'd like to ask if I can take a picture with everyone here up front with the devices in your hands. Yeah, if you can bring the battery so the light is on, it would be good. And also, I have some stickers here on this desk, so if you want to grab one, feel free to grab and return the devices here.
You want to go on the
Attention, everyone. After the photo, please leave the devices on the table. Or if you are interested to purchase one of these, please reach to Juliana to get more further information. Thank you.
Everybody smile.
Wearing your masks.